So today, at least just for you, we're recording, but I'm going to attempt to not do my Mr. Mood recording voice. We're just going to do just a regular voice. Regular.
You like a talk show voice?
Oh, that would be good. My talk show voice would sound more like this.
Yeah,
All right.
sound like that guy.
All right. Yeah, help the family. We're going to do a little math. All right.
Joe.
Is that okay, Elise? Can I talk like this? All right.
Okay.
Now this right here, this is an absolute value inequality. All right, saying the absolute value of 4x minus 10 is less than or equal to a 6. All right. Now remember, how many answers are we going to come up with?
3.
No, not 3. 2. Thank you for playing. All right. Now, what we're going to do is I want you to understand that 4x minus 10 technically could be less than or equal to 6. Right? That's what I'm doing. Really? Could you please turn your ears on? Thank you. All right. Now, I'm also going to do a negative version. So 4x minus 10, this is going to freak you out, so don't let it freak you out too much. It's going to be greater than or equal to a negative 6. And you're like, wait a second. How did the sign change? Why did it change?
Because it changed to a negative.
Right. Because if you take this right here and you change it to a negative 6, what happens to the inequality sign? It flips. So we're going to solve both of these. We're going to have 2 answers. So just remember this. One answer is the positive version, but when you change it to the negative version, you have to flip the sign. By the way, I'm going to change to blue because I like that color. And we're going to do the exact same step for both inequalities. What would be that step? We're going to add a 10 all the way across. Just like that. Brilliant. Right? Look at the one. Could you tell me what I'm going to have left right over here?
4x.
You got it. It's a 4x because that's a whole lot of zeros. We've got a less than or equal to, what is that?
16.
You got it. Excellent.
Oh, and then divide.
Well, hold on. We're going to wait for this. What about this side?
I'm not that deep.
We'll catch up.
4x.
4x. Greater than or equal to?
4.
4. As this zeroes out, this becomes a 4, so I just bring it down. This became a 16, so I just brought it down. Now, Ryan, what you wanted to do, but I told you not to do a few seconds ago, but you really wanted to do was
Divide by 4 on both sides.
everywhere, all the way across the board. We're going to divide by 4. And why did you choose 4? Because that's the number right in front of there. Very easy.
Yeah.
All right, so we've got a positive one over here. It's less than or equal to a
4.
4. And then this one worked out to what?
X
X
equals
is
1.
close.
All right.
X is greater than or equal to 1.
There we go. So we've got 2 answers. Whenever you're solving absolute value inequalities, you're not going to have one answer. You're going to have 2. Okay?
Are you going to show these to your next pre-calc test?
No, because my next pre-calc class is not until tomorrow.
No, next year.
Next, I don't know.
I was going to say, man, my voice is being.
I will say these. Maybe somebody from next year will see them, but I'm not going to use them to teach.
Okay.
But they'll have to like take the time and energy to go to the web and actually search them. So, yeah.
Oh, wait, so this is going to be on YouTube?
Yes.
Well, I'm going to go look up this.
You won't be able to find it unless you go to the web page. So right here, I want you guys to put the number 0. All right, back to normal. There we go. All right. Then right here, I want you to put the number 1. And over here, put the number 4. Now when you see this equal, see less than or equal to, make sure you put a big old fat solid dot right there because I'm including the number 4. And over here where it says greater than or equal to a 1, you're going to put another dot. Make it nice and fat. There you go. You're basically, by making it solid, you're saying, I'm including that number. Alright? Now, we're going to shade. It says what? Less than or equal to the 4, so that's going to go this way. And then over here it says greater than or equal to a 1, so that means it's going this way. So our actual graph, if I told you to graph it, this is what it would be. This is in your journal, so you want to have a graph in your journal. Help you understand the problem. There you go. We're only spending one day on this as a review. Okay? So, all of your x values are between the 4 and the 1. But then, something you haven't done in a while that you need to know how to do is set builder notation.
Oh my gosh, that was like last year.
Set builder notation. So how do I write this as a solution set for the inequality? Here's how you do it, right? You're going to make a cool little bracket. Think of it as like a sideways mustache. Okay. You're going to put x right there. And you're going to put this cool straight line that looks like that.
This is the answer to how you write it.
This is the answer to how you write it. All right? This part right here means the set of all x values such that. That right there. All of that. That symbol, that symbol, that symbol, basically is all those words. Give you a chance to write that down. I'll pause. All right, so the next part, we're going to change colors. All right, going to change to blue. Now, would you agree this x right here is between a 1 and a 4, including the 4 and including the 1. So we're going to put the x value right here in the middle. All right, we're going to put the 4 here. We're going to put the 1 here. I want you to understand you put your big number, like the maximum number here, and you put the minimum number right now. By the way, Tyler, in your real answer, you don't have to put max and min. It's just for your journal to help you realize where the numbers go.
I figured that.
All right. Now, x is less than or equal to 4. And x is greater than or equal to a 1. And then you close the bracket.
How do you know what sign to use?
All right. So we're going to scroll up just a little bit. Scrolling up. Okay. Now, follow the hand right here. I'm waving at you, see? All right. So this says x is greater than or equal to a 1. Now, see how the mouth right there is opening up to the x?
How do you not need that?
See? Look. Is the mouth still opening up to the
X?
Yes.
Mouth.
Mouth opening up to the x. Over here, this says what? X is less than or equal to the 4. So you put the x is less than. So which one looks the easiest to recognize? The what? X is less than or equal to a. So I always set up the biggest number on the right side, and then I follow the pattern of the inequality and work my way to the minimum value. Okay? Yes? Question?
Is it always going to be the one on the problem? Like, you know how that in the problem is originally that one.
Right, so basically, this right here, if it's shaded in between the two numbers, if everything including the two numbers and everything in between, this is how you're going to write it.
What if it's not?
What if it's not? It's a good thing we're doing problem number 9. So right now, put problem number 9 in your journal. This is the last one we're doing together. So I'm zooming in on problem number 9. Okay? Now, after you write problem number 9, the first thing you have to do is do what? You got to take away this 2 from both sides. So here we go. Here's what you're left with. The absolute value of x plus 5 is greater, not better, than 4.
Why can't you combine 5 and 2?
Because the 2 is on the outside of the absolute value, and the first thing that you have to do is to isolate the absolute value expression. So right over here, I'm going to write most important step before you start doing anything is this. Isolate the absolute, it's supposed to be enough, value inequality. Oh, I mean expression. Absolute value expression. Just remember, the absolute value expression is this part right here. Once you've done that, Liz, now you can separate it into two inequalities. One's going to be evaluating a positive 4, one's going to be evaluating a negative 4. The easiest one to write is this. X plus 5 is greater than 4. So this expression right here could be greater than a 4. The trickier one is this. X plus 5 could be what? Less than a
4.
Nope.
Negative 4.
Negative 4. So that right there, remember, when you change it to a negative, what happens to the sign? It changes.
Opposite reciprocal.
No, that's no. So that right there is dealing with perpendicular lines, which is a geometry concept, which is what we're not talking about. Okay. But Ryan, there's one step. You can tell me the one step that goes all the way across.
-5 on all sides.
There you go. You got it. -5, -5, -5, -5. In one fatal swoop, we can eliminate everything that we need to.
Okay, you ready?
I'm ready, Ryan.
0.
Okay, that's 0, right?
Yeah, x greater than -1.
All right, good.
And then x.
All right, I'm going to change my color here.
Okay.
Got it?
Is less than -9.
You got it. Those are your two answers, everybody. We've got x is greater than -1 and x is less than -9.
Question are we on that?
We're on question number 9.
Oh, okay.
Now, I'm going to use the number line once again to help us figure out what's happening in the problem. Here's the problem. Right here, I'm going to put a little 0. Right here, I'm going to call that -1. And way over here, I'm going to put a -9. See, there's a -9 right there. There's a -1 right there. Now, by the way, do you see any equal to signs?
Yeah. Oh.
No. If you don't see an equal to sign, you're not allowed to put that cool filled in dot. You got to leave it as an open circle. Open circle.
There it is.
Because you're not including the -9 and you're not including the -1. Right? Leave it open. Now, let's think about this. What does this statement say right here, Shayla? What does that say? So we're going to look. X is greater than -1. That's going that direction. What does this one say right here? X is what?
Less than -9.
Which means I'm going which direction?
The same.
Not the same way.
Different way.
Going the opposite direction. You're saying that's going less than, that's going greater than, which means this is not an and statement. This is an or statement. This means this is a solution or this could be a solution. We're going to write this one differently. Now, question. Do you see the difference between this graph and, hold on, wait for it, this graph?
Yes.
This is connected.
That one's a right.
Stop talking. All right? These are going opposite. Yes, it does look like a geometric ray, but we're dealing with an inequality. These are going in opposite directions. Okay? So how do we write this graph as a set of solutions, like an inequality solution set?
Okay.
Make that cool bracket. Put the x. This is the set of all x values such that you're going to write it like this. X is less than -9, or x could be greater than a -1, and then you're going to close the set. This is how you would write it in set builder notation. And once again, as I